All right. Hello, everybody. Welcome to officially our 10th fireside chat of the Vercel AI Accelerator. Thank you all for joining us this Friday evening. Today we have Erik from Banana.dev who's going to come and talk to us about self-hosting and kind of, lessons on how to self-host your own models and kind of the joys and pits of running that, basically that own inference backend. And obviously talk to us a little bit about Banana.dev, which is an official partner of the Vercel AI Accelerator as well. And they've generously given us a bunch of credits. So without further ado, thank you for joining us, Erik, and take it away.
Awesome. Hey, everyone. Thanks for having me. Really appreciate this. Let me share this little presentation I pulled together, and we could get going. Cool. Nice. So the topic of this presentation is what to expect once you go beyond the APIs. A lot of teams running in the Vercel AI Accelerator, I'm sure, are running on common APIs such as OpenAI. My experience for the past 3 years has been operating beyond the API. So I'm excited
I think
to
we
tell you
lost
all.
audio, Erik.
Oh, that's a
It's just
bummer.
me?
I could hear. I mean, it says my audio's going.
Let me make sure.
Can anyone else in the call confirm?
Oh, sorry. I think you're good.
Cool.
Sorry about that. Go ahead.
All right. Yeah, so a lot of my experience the last few years has been going beyond the API and helping teams move past calling a third-party provider. So I'm going to talk about that today. A bit of Banana lore. We've been on operation for almost 4 years now, starting back before the GPT-3 wave. 2019, we phrase ourselves a bit as an MLS and API platform, similar to OpenAI, but also open source providers such as Replicate, where you effectively come to us, find an off-the-shelf model. And we did this during GPT-3, during the surge of, I call it the first wave of AI companies, real-time AI companies, a lot of them in the copy generation space. You all know names such as Copysmith, Copy AI, Jasper, Otherside AI. We worked with some, if not all of them, helping them set up their own custom fine-tunes, their own custom backends to run their APIs in as an alternative to running on OpenAI. And doing that, we realized it does end up devolving a bit into doing a lot of custom API implementations, but doing implementation after implementation, trying to win these deals. We learned a lot about how to serve alternative models in production. And then we took those learnings and launched that at 2022 as our serverless GPU platform, conveniently well timed for the current AI hype wave. So that's gone really well for us. We've had a lot of fun growing the team, raised some money, and we are here to serve you. So I'll be talking a bit about that at the end, though. Before we go to the, AI startups. We've just seen patterns with our customers going through the same set of patterns over and over, starting on APIs, slowly moving to their own custom code. Over the 4 years we've been doing this, we see how it's done, and it's sort of hard to see large companies running in production without some form of self-hosting. Though on the disclaimers, a lot of this advice isn't going to be relevant to teams right now. I think it's important to call out the pitfalls before they happen, so you could be aware when they're coming, what to expect. I'll say it later, but I encourage staying on the APIs as long as possible. A second disclaimer, I'm giving advice about how to self-host APIs. I'm the founder and CEO of Banana. I'm here to shield Banana. But again, ironically, I will be encouraging everyone to stay on APIs as long as possible. So those are the disclaimers. I'd be curious, a little audience participation. Who here is exclusively on the APIs right now?
Well, I am for my personal projects. Looks like
Nice.
Chris is as well. And I know a lot of folks here are on APIs.
Yeah.
I don't know if anybody's doing self-hosted yet.
Well, that's good. That's where you ought to be starting. And I feel like the majority of teams should start there. Hopefully this is relevant. As you're thinking about your APIs, I'm sure you have these things on the top of your mind. We call them the 4 pillars of AI backends. You want your API or whatever service it is to be high quality, high reliability, low latency, and low cost. it really, really depends on the type of company that you're running. So you basically need to pick your poison between these. They often become interchangeable. You can gain latency. You can make your service faster if you're willing to pay more. You're willing to get higher quality if you're willing to pay more for, say, the newest API model on OpenAI and such. Though this really comes down to you as a team, just keep in mind these factors: quality, reliability, latency, and cost. They're present throughout your entire journey. You're always going to be fighting, hey, what is the alternative of running on APIs versus rolling our own? You'll be making trade-offs. So keep that in mind as we go through this. Generally, the stages of building out your AI backend, we have a rectangular Venn diagram here over time. So generally, you start on the left side here, which are the multi-tenant APIs. And I really want to highlight multi-tenant because that becomes important later when thinking about self-hosting. But these are things like GBT, Cohere's embeddings, Anthropic, as well as anything agent-based. Effectively, if any work is being done on a GPU on a third-party provider that does that as a service, as an API, it's good to think about it as, a multi-tenant API. And this is generally where I encourage teams to start. I think once you get into like agents and embeddings, you're starting to get a bit more tricky about the way you're using the data from the models. It's not just pure string in, string out, or string in, image out. You get tricky, but ultimately you're not touching GPU, so you don't have to feel the pains of dealing with that. The pros of working on APIs, the quality is passable. You could get to product market fit with just APIs, and that's what I encourage. The APIs are built by a business that are selling it as a product. And what this ultimately leads to is it's multi-tenant, as in when you're not using that GPU, someone else is. So these providers can afford to charge you just per inference or per token. The machines are always warm. There's no cold boots. They handle all the auto scaling for you. And it ultimately just makes a hyper optimized API run by specialists who have been implemented it in C++ or whatever to make it as fast and cheap as possible. And I think most important as well, biggest pro of running on an API is just no headaches. I think there's so much distraction to be had in self-hosting that just try as long as you can to stay away from it. And I really like this phrase. This is the founder of Dust. No GPUs before product market fit. I think it's, especially with the current hype wave of things, it's easy to let a demo run away from you. You think that you have product market fit and you stand up a bunch of GPUs, dump tens of thousands of dollars into that, and then maybe the shark fin subsides and you're back to square one, but with a bunch of GPUs. I think it's good to realize that generally these shared APIs could get you most of the way to product market fit, if not all the way there. And then only then do you start trying to optimize. Cons of APIs. These are worth noting, and these are one of the reasons that back when we were effectively an API consultancy, a lot of the reason that users came to us, which is they wanted to build a moat. And this is what you start thinking about post product market fit is, if you have some magic in your project that's fueled by AI, but it's the same AI that your competitors are using, it's a bit hard to think about how you could differentiate. You have to get into, the actual user experience, which is a bit harder to nail. So that's one aspect. And another aspect is dependence on API providers in general. Perhaps they don't like the use case that you're applying the AI for. Perhaps, they just go out of business if it's a smaller startup that's hosting the API for you. You could be in existential risk if you're dependent on this API provider as the main engine for your product. So those are cons. There's only two of them. That's really what it boils down to, but they're pretty massive, pretty existential for companies. So it is good to think about these early on. There is a cool middle area in the Venn diagram before you get to self-hosting, which is managed fine tunes that I want to talk about. With APIs, you can get pretty far with prompt engineering. And if you want to add another layer on top of it, a lot of the API providers also offer managed fine tunes. So OpenAI, for example, they have an interface where you can upload, say, text or some training data, and they'll train a model for you and host it for you. So effectively, they're still running the same API skeleton, the same business logic as before, but they just drop your weights on top of it. I think this is a really interesting offering and something I'd encourage people to experiment with if you feel like you're hitting a quality wall with the existing APIs. Um, but you start paying a lot more for these, and this is where the price starts going up. Because it's not a multi-tenant API, the providers generally have to charge quite a bit more to justify, the GPU time in which you're not calling the model. So keep that in mind once you get to manage fine-tune stage. And from this point onward, once you start thinking about training, once you start thinking about custom code, it's really good to set yourself up for success. So where do you get your training data from? What I'd recommend right now, actually applicable at this moment for everyone here, is if you plan or suspect at some point you'll get to doing your own custom trained models, capture as much data as you can at the moment. Even if it's data generated by these large models, treat it as synthetic data. You have users interacting with, the result of a generation, or ultimately some like UX experience that is fueled by these models. And if you want a better quality model, you could understand through the way your user interacts with your product, how good was your previous generations, and basically store that with a thumbs up, thumbs down, or some ranking score that classifies it as a good generation or a bad generation, because that future you will thank you for having that data. So little tip for right now, and that helps you get into managed fine tunes. And then the next stage, which I'm sure y'all are dying to get to, self-hosting, which I wouldn't encourage going into lightly, as you could tell. But our job at Banana is to make this as easy as possible. So challenges of rolling your own infra. First of all, is procuring GPUs. There's a lot of great providers like CoreWeave, Lambda, AWS, GCP, Azure. Though I have found with the current capacity pinch, it's becoming harder and harder to get GPUs. And we're more often than not offered GPUs through, friends who just are running some cluster somewhere in some warehouse, and it sort of feels like a drug deal. When you're out there trying to find GPUs, go to the big providers first. That's where you're most likely to find it, but you may have to get creative in finding GPUs. Next challenge is orchestration. So orchestration, for those who don't know the term perfectly, it's basically how do you take a set of hardware and deploy applications to that. This is where Kubernetes works. There's really no mature platform like Kubernetes built for GPUs and ML workloads. Kubernetes, you can make it work, and actually previous versions of Banana ran on Kubernetes. But you do have to build a lot of primitives on top of it. And on the topic of orchestration, cold booting. This is a big topic in serverless. And effectively, the idea is that if you want to handle peak traffic, say you have 100 calls per second, and it takes 1 second to process a call on a GPU, that means you need 100 GPUs, but that's at peak traffic. If your average traffic is 10 GPUs or like 10 concurrent requests, you're pretty much left out to dry, because these GPU platforms don't auto scale GPUs as fast as you need. GPU platforms like AWS, Azure, GCP. So you pretty much need to assume you're running a static cluster, and you burn a lot of money on unutilized GPUs. So that's the orchestration challenge. And then lastly, there's just some DevOps challenges, like making sure your machines are compatible, making sure you have CI/CD set up, and just like setting yourself up for success on your cluster. Lots of pains in doing this. Lastly, just waking up and fixing prod. You have other things to worry about. This is the whole headaches thing of running APIs. Is ideally you don't want to think about these things. But there's a better way.
About cold boots.
Yeah, let's talk about cold boots.
Yeah, so you mentioned that's a big part of serverless in general, and I agree. But how do you all personally deal with it, and how does it work? So for example, say I'm a user, I want to try out a new API, I want to try self-hosting it, let's say like segment anything from Facebook, yep. Right? And I think you guys have a template for that as well. So I can go on into Banana and deploy that template. But let's say I'm only using it, doing like 10 API calls a day or something very, very low usage. Yep. How do you all think about cold starts with that? And do you ever like pool resources together? Like if I'm using it and somebody else from the cohort deploys it on their own account, like do we share an instance of that model? I'd love to hear how you think about that.
I mean, the sharing thing, ultimately multi-tenant, it's been a lot of internal discussion about what we want to do there. I think in our time, consistently seeing teams move off of APIs and onto custom implementation, we view shared APIs as a short-lived experience within a AI startup's life, and it's important for us, rather than masking the cold boot problem, to simply solve the cold boot problem. So as much as like we have considered how do we hack this to make it seem better, we don't want a user moving from, say, a pool, like a shared resource API that they've been running, not knowing it was shared with others. And then, they deploy their own thing and suddenly it's way slower for some reason. I think it's better to just, try to work on the core problem in the first place. Though we do, we certainly have hacks to make cold boot as fast as possible. I'd say it's the most important tech that we work on at Banana is getting your Python up and running as fast as possible. And we've actually had to make a lot of hard, opinionated takes in order to make it happen. That I'll be showing in a demo later. So you'll see some live cold boots during this demo.
Awesome.
Cool. Any other questions before I jump off?
No, not for me. And for everybody else, feel free to use the
I'll
raise
open the
hand
chat.
Zoom feature, put them in the chat. Yeah, as we go on.
Nice. Oh, someone loves the Banana logo. Thank you. Frank gave it to me. Cool. So continuing on, but there's a better way. Rather than self-hosting, you can use Banana. There are other great providers as well, but I'm here to show Banana. So let's do a demo. I'm going to break out of this here and open up the Banana dashboard, show you what it looks like to run an API on Banana. So here I have a BERT model. It's a pretty lightweight text classification model that we run. And this is our hello world on Banana to get started. The models themselves are almost exactly like Vercel. They're deployed automatically on push to main on GitHub. So you integrate your GitHub. This is the integrated project here. It has an app.py, and this is where your application logic lives, very similar to a Flask for those who are familiar. Given a init function to load heavy models into memory, and then you have a handler function to actually run the model here. So hopefully pretty easy, hopefully pretty familiar. You push this to main, it builds, deploys, and you have a callable endpoint here. We give snippets in order to call your endpoint directly. For example,
are you sharing your screen, by the way, Eric?
Oh, shoot.
Yeah.
I thought I was sharing my whole screen.
No, I don't think you've shared your screen.
Have I shared at all this whole time?
No.
Oh, no. Okay.
You had slides? I didn't even realize.
There goes my hard work on my slides.
Okay.
Let me get
a couple of people in the chat are
oh, that's a bummer.
Yeah.
Okay. I had a few good visuals. Let me recap. 4 pillars. Venn diagram.
No, we still can't see your screen.
Oh my gosh, what's going on here?
Yeah.
I could build a startup, but I can't do this. This is silly. Okay. There's the share button.
Nice.
Okay, now. Okay, cool. That's a bummer. Let me show you the cool memes I had in here. We got that. We got this. And it's time to chill. Okay, so demo on Banana.
Nice.
I'll share these links. I'll give this to you later, Hassan, if people want to reference it. But on Banana, this is what a project looks like. You have basically your dashboard for the model. Models themselves are deployed off of GitHub. Let me move this. How do I get rid of that? All right. They're deployed off of GitHub. Here, this is the GitHub app that is deployed on Banana. We have effectively similar to Flask, where you write endpoints with decorators. So here's a handler running at the root. This handles traffic calling to there. It's a post request handler, and you use a model to basically run your inference. And that's deployed to Banana. We give you a little curl command here. A curl command here that I could drop into a terminal and show you it working. So I'm going to call the model here. This is where we see the cold boot. You can see replica warming up here. Depending on the model, depending on the size, it could take anywhere from say 5 to 20 seconds Super large models, like they could take a bit longer, but we'll get a BERT model up and running. You see it just turned green there, which means it's live and ready to go, and just returned a result here. Now that it's warm, I could call it back to back. It's already warm, ready to go. Only a few hundred milliseconds in order to actually run it end to end on the warm replica. And then it's configured to scale down when you're not using it. So it scales to 0. After about 5 more seconds here, the instance will shut down and it is now cold again. That's configurable. If you want to keep your instances up for longer, you are free to do so. And I also have a script here to show what load testing looks like and what it looks like to get to multiple replicas. So I have, I don't know if you can see the screen here, but this is what the Node SDK looks like. We initialize a client with our keys. We have the inputs for the function, and we call it in this run function here. And we do this every 1 second. So every second we're sending a call into the system. And remember, it takes a while for the calls to warm up. So I'll show you what that looks like when we actually run it. So we start streaming calls in every second. You're going to see in the UI, our machine scale up. I have this configured to max replicas of 10 so I don't get overbilled. And basically these 10 replicas get started up and they start cranking through the jobs. And it'll take, again, like 10 seconds for a BERT model.
Very cool.
Yeah, it's a good time. And this is the suspension part of the demo. There we go. So we got some machines live, green there. They're working. They're returning results. And you can see now it's calling every second. It takes less than a second to actually run the job, which means theoretically we only need 1 replica. And Banana detects that, and we detect if you're overscaled, and we basically scale you down to the minimum quantity of replicas that you need to handle that sustained load. So got my call per second still running here. It'll just keep running until I shut it off, and then this machine will shut down like this. So again, 10 seconds, it'll pop off, and then my billing stops metering. Also, thanks, Chris. Appreciate the comment. And that is the demo of Banana. Again, it's built around pushing to GitHub as the main interaction. Y'all are very familiar with it on Vercel. So if I were to say, make a PR here onto my app, commit that, and then go back into my model, it's going to go into the building state right here. And my build logs, build started here, builds, deploys, same sort of deal. We ultimately want to start working in features like branch deploys, like mono repo support, things like that. A lot of the things you see in a Vercel-like product. But for now, this is what we have. Going back to my beautiful presentation, we offer credits through Banana on the Vercel Accelerator. Here is Vercel AI 23 is the code. You could put that into the UI, into your account here in order to add credits to your account. It's only usable once, and that will give you $500 credits to run on Banana. I'm also at Erik@Banana.dev. Please feel free to reach out to me if you, firstly, if you just run into issues, but secondly, I'm happy to just sit down with you and set it up with you if you're wanting to get to this point. Again, generally, no GPUs before PMF. But once you do get to that point, you're ready to talk. I really want to be here to help you. So that's it. Very open to questions.
Awesome. Thank you so much, Erik. That was great. I love this. I love the statement of no GPUs before PMF. What do you think is the right scale, or I guess with some of your customers? Because you said, if you're just starting out, use an API, and then gradually you'll move on to self-hosted. Do you have a gauge for what the right whether that's spend or number of API calls per day or per hour? I'd love to get an idea of what you have in your mind.
Yeah. Well, a surprising pattern that comes up is your workhorse, your main workhorse model, stays on the APIs for quite a bit of time. And then over time, you start building up these ancillary services, for example, like labeling or tagging, or so you wanted to add some transcription to your service, for example. You start tacking in additional models that work in pipeline with that hosted API. So oftentimes it's almost a hybrid approach. At first, people start easing additional greenfield projects onto Banana. And then beyond there, once you get to like super high throughput serving, teams will spend up to like $1 million a month on GPUs before they're really thinking about hopping ship and figuring out how to host it themselves. So if that's any sort of threshold, that's generally what we see.
Gotcha. That makes sense. Well, I'm going to go ahead with another question if nobody else has any right now, if that's fine. So what are some like good use cases to use Banana for? I know you talked to us about it. Like, it seems like it's a very general platform. Like, it doesn't even have to be machine learning related technically, right? The repos that you deploy onto it. But yeah, what are some cool use cases or some popular use cases that people have been using it for lately?
So the killer use cases are, well, anything Stable Diffusion and Whisper tends to be the big models that are ran on Banana. Part of assessing when to move off of APIs is, where does quality make sense to take the leap? And with like pure text generation, even larger models like Vicuna or Llama, it's sort of hard to justify running those when OpenAI has a cheaper offering for arguably better quality. So like pure play text-to-text LLMs, don't see as many of those on Banana. Though we do see a lot of people working with transcription, a lot of B2B transcription apps built on Banana, as well as more content-related Stable Diffusion type apps. Though, we see users pop up in our cluster all the time with completely unexpected use cases. We've even had people just run video editing software on our GPU backend without even running models. So it's arbitrary Python, so you can do whatever you need.
Nice. And then the last thing I wanted to touch on real quick is pricing. Yes. So generally, like, how does that work with Banana? And if I'm deploying, like, I always like to think in terms of number of API calls, or maybe also like how long those API calls will take on an A100, right? So if I'm doing 1,000 API calls a day and I know each API call takes 10 seconds, like, what can I expect my billing to be?
Yeah, so just to temper expectations around moving off of the APIs onto self-hosting, it's not uncommon to pay 10x more for the same thing, like on a per token basis. And part of that's just the multi-tenant aspect. So it really is, is the quality that worth it to you to just get that slightest bump over the APIs? In terms of billing scheme on Banana, we charge machine time rather than per token, just because it's arbitrary compute in our eyes. So you could actually see my balance up here if I were to start running calls, running the same script. You would see this tick down a couple cents, like every few seconds, or not even every few seconds. Ultimately, the machines come out to be, I think it's, oh gosh, I don't want to quote our current pricing, but it ends up being like $7 an hour per GPU. But part of that's with the auto scaling, since you're not paying for it when it goes down to zero. So it ends up, users end up spending $10 a month hosting on Banana. That theoretical project you mentioned before that's running 10 inferences a day would be pennies.
Gotcha. Thanks. Yeah, that makes sense. Cool. Well, does anybody else have any questions? Because if not, we can wrap a little early, or if you have something else you want to show us, Erik, that'd be great as well. Up for anything here.
I don't have anything top of mind.
All right. Awesome. Let's wrap early then.
Cool. Let's do it.
Thank you so much, man. I appreciate you coming through. This is great.
Of course.
And I'm glad we saved the slides where you showed us a couple of the tweets and most importantly the memes. So I'm glad we had a chance to look at those.
I'll be sure to share the slides. Just so my hard work is not forgotten. Yes. Appreciate it.
All right, thanks again, man.
Nice. Yeah. Thanks everyone. Have a good one.